In this video, we're going to be investigating equivalent linear relations and equivalent linear systems. So let's jump right in with our learning goals. By the end of this video, you should be able to 1. Identify, graph, and create equivalent linear equations, and 2. Identify, graph, and create equivalent linear systems. We've got two key terms for today. So an equivalent linear equation is an equation that has the same graph. So that means after you plug everything in and you graph your lines, the graphs are exactly the same. Now equivalent linear systems, this means that a pair of linear equations, they have the same point of intersection, although the graphs appear different. All right, let's start with our first learning goal here, identifying, graphing, and creating equivalent linear relations. So let's pull up the first question here. So it says, without graphing, identify which of the following are equivalent linear equations. So we're just going to focus on the identify part of the question because that's the part of the learning goal we're going to focus on here. So what we need to do is to rewrite these into y equals mx plus b form. So one of them is already written this way. We don't need to do anything. So let's start with the one on the left. Okay. So y is already positive, which is great. I always like working with y, whether it's positive or negative. So I'm going to rewrite this, y equals, and bring the x over, so that becomes positive x becomes minus 5 plus 0. So when we write it, y equals x minus 5. And then we can go to the one on the right. It's got y on its own as well, but we have to isolate it further. We can do that by dividing everything by 2, because what you do to one side, you do to the other, and that gives me y equals x minus 5. So I didn't even have to graph either of these to find out that this, let's get a better color here, that these linear equations, if I were to graph them, would be equivalent. The graphs would be exactly the same. So as I was just stating, equivalent linear equations have the same graph, and for any linear equation, an equivalent equation can be written by multiplying the equation by any real number. So we're going to break down the other two parts of this learning goal here. First, we're going to stick with graphing. We're going to create the same graph. So let's put up our question. On the same grid, graph the lines x plus 2y equals 4 and 2x plus 4y equals 8. So let's grab our grid and start. All right, I'm going to grab a couple colors here. So I'm going to work with pink and green. Okay, so we need to rewrite these. I always make a note somewhere. I just like to have that for referral. So let's rearrange here to have y on the left of the equal sign. So we've got 2y equals negative x plus 4. Now we have to divide everything by 2 to isolate for y. So that means y equals, now don't get confused here because there's no number in front of the x. Remember, there's actually a 1 there, right? So y equals negative 1 over 2x plus 2. So let's go ahead and graph this. This is my y-intercept, so I'm going to start at 2. And then I have my slope here, so it's negative, so I'm going to go down 1 and over 2. All right, here we go. I'm going to go down 1 and over the right 2. Down 1, over 2, down 1, and over 2. And remember, we can always reverse it. So instead of going down 1, I can go up 1. And instead of going to the right, I can go left. And I can go up 1 and then left 2. Once you feel you have enough dots to draw your line, you can do so. So there's my line here. Excellent. Now, let's rearrange the second linear equation that they gave us. So, try and get y on its own on the left-hand side here. It's going to be negative 2x equals 8. And I've got to divide by 4 to isolate for y. If you look carefully, you may already have noticed some similarities between what's going on here. So I cancel this out. I'm going to get y equals negative 2 over 4 is actually negative 1 over 2 when we reduce it. Okay? Sorry, this should say plus 8. I wrote equals. And when we divide, we get 2. I've got a y-intercept here that also starts at 2. And then my rise and run is down 1 and over 2. Down 1 over 2. So you'll see the graph of these two linear equations is exactly the same. So now we've completed the first two parts of this learning goal. We identified equivalent linear relations, we just graphed equivalent linear relations, and now we can create equivalent linear relations by multiplying the equation by any real number. Now, I already drew your attention to what was going on here in this second line because they did something here to make these equations equivalent. What do you think they did? Let's write them one above the other. So we have x plus 2y equals 8, and then we have 2x plus 4y equals, my apologies, this should be 4, equals 8. So we can see here, all they did was multiply by a factor of 2 to get an equivalent linear equation. So let's use the same one at the top, but let's multiply by something else. Let's multiply by 3. So instead of x, I'm going to have 3x. Instead of 2y, I'm going to have 6y. And instead of 4, I'm going to have 12. And I'll show you how this new linear equation that we just wrote is going to be equivalent to the 2 that we just graphed. Let's isolate for y. So I've got 6y equals negative 3x plus 12. I'm going to divide everything by 6 to isolate for y. Y equals negative 3 over 6 is actually equivalent to negative 1 over 2. And then 12 divided by 6 is 2. So I've got 3, 1, 2, 3 linear equations that are equivalent. And this is what they look like when they started. Now we're going to move to the second learning goal, which is identifying, graphing, and creating equivalent linear systems. So our notes for this are: equivalent linear systems have the same solution, which means the point of intersection, even though their graphs are different. And for any linear system, an equivalent equation can be written by adding or subtracting the original equations. Okay, so let's give this a try. Let's put our question up. They're asking us to graph. I'm going to move our graph up a little bit higher. There we go. Okay, so graph the linear systems and find the point of intersection. So what we need to do is, let's pick our colors. We're going to rewrite both of them into y equals mx plus b form. So 2y equals negative x plus 4. Divide by 2 to isolate for y. Y equals negative 1 over 2x plus 2. And then we'll do green for this one. So it's x minus y equals 1. So I've got negative y equals negative x plus 1. Divide or multiply, it's up to you how you want to get rid of your negative. And we're left with y equals x minus 1. All right, so let's go ahead and graph these. Okay, so I'm going to start with my y-intercept at 2, and then my slope is down 1 and to the right 2 again. So we're going to go down 1, to the right 1, 2, down 1, 1, 2, down 1, 1, 2, and I'm going to continue it upwards as well. So instead of down, I'm going to go up 1. Instead of the right, I'll go left 1, 2. And I'm going to draw my line. That wasn't so great, was it? Doing my best here. Okay, and now let's graph our second linear system here. We know that in front of the x there's a 1, so that means my slope is going to be 1 over 1. And I'm starting at negative 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to continue it downward just to draw a nice big clear line. Again, you can always draw as many dots as you feel comfortable with to get your line to be accurate. So our point of intersection for these two lines right now is 2 and 1. Now what we're going to do is we're actually going to create an equivalent linear system. Let's do so by adding. So I'm going to take my two equations that I got here, and I'm going to write them one on top of the other, almost like an interesting addition problem. Let's just say we were adding these two together. X plus x would give me 2x, 2y plus 2y minus y. We would just get y. And then 4 plus 1 is 5. Let's rearrange this and graph it. We'll give it a different color. Let's give it blue. So if I rearrange this to isolate into y equals mx plus b form, I'm going to get y equals negative 2x plus 5. That means my starting point is at 5. 1, 2, 3, 4, 5. And then I'm going down 2 and to the right 1 for my slope. 1, down 2, to the right 1. I'm going to go down 2, 1, 2, to the right 1. Down 2 and to the right 1. And for this one, I'm going to go up 2 and to the left 1. I'm going to draw. So what you should be noticing is that by adding the left sides and the right sides of these two equations, we created an equivalent linear system to it. Well, we created another equivalent linear equation that in this system, we created another equivalent linear system, which is because the graph is looking different. We have 3 different lines. If you recall in the beginning of the video when we started drawing lines, they were overlapping each other. We can also do this by subtracting. So let's try and do that. So let's rewrite. You've got x plus 2y equals 4 and x minus y equals 1. If we trying to create a big thick symbol there so you can see it, subtract, well, the x's are going to cancel out, right? And then we have 2y minus y, So 2 negatives is actually a positive, which equals 3y. And if we subtract 4 minus 1 is 3, we can divide by 3 and divide by 3. Y equals 1. I'll do this one in yellow. Y equals 1. Well, what does that mean? That just means I'm going to go on my y-axis. There's no rise or run. This is simply a straight line. Okay? And you'll notice it intersects at the same point. So by adding or subtracting the original equations, you create equivalent linear systems. I think there may have been a problem there towards the end where I was looking down at my iPad and writing, but nothing was appearing on the screen. So I'm just going to leave this up here for you to copy as you need, because I'm not re-recording a 16-minute video just to fix the ending. So that's it. Voila, there is your equivalent linear system. You can see that if we did this all on separate graphs, all these lines would look different, all the graphs look different, but they share the same point of intersection.